July 27, 1944. Wait 47 hours. St. Lo, Normandy. Foyer. The 88mm KWK-43 gun recoiled violently inside the Panther's turret, the breech slamming backward as the shells screamed across 200 meters of Norman hedgerow. Through his Turmzelfernrohr gun sight, Unteroffizier Klaus Becker watched the tracer arc perfectly. A textbook shot into the Sherman's right sponson, exactly where the ammunition racks sat exposed above the drive sprocket. The impact was clean. Metal shrieked. White-hot fragments erupted inside the American tank's hull. Becker's loader was already reaching for the next round, muscle memory from 2 years on the Eastern Front. His commander leaned forward, waiting for the familiar sequence. First, the black smoke curling from hatches, then the orange eruption as 70 rounds of 75mm ammunition cooked off in a cascading detonation that would consume the crew in seconds. 3 seconds passed. Becker's eye never left the sight picture. Any moment now, the sponson hit guaranteed it. Every combat report from Tunisia, every tactical briefing, every burned-out Sherman Hulk he'd seen from Kursk to Cannes confirmed what came next. 5 seconds. "Brent nicht," the gunner muttered. "It's not burning." 8 seconds. Then the Sherman's turret began to traverse. The movement was smooth, mechanical, deliberate. The 76mm gun pivoting with the cold precision of a predator that had absorbed a killing blow and refused to acknowledge it. The barrel swung toward them, locking on with terrible certainty. "Scheiße!" The Panther's commander grabbed the loader's shoulder. "Laden! Schnell!" But the loader had frozen. The next round halfway to the breach, his face pale in the turret's dim light. "The shot was perfect, Herr Oberfeldwebel. Right in the ammunition." The Sherman fired. Before we continue, click that subscribe button, like this video, and let me know in the comments where you're watching from. It brings me great joy knowing that these war stories and lessons get to people all over the world. Your support helps us bring more thrilling war stories, and trust me, you won't want to miss them. Now, let's get back to the story. The German crew felt the 76mm shell pass overhead, close enough to hear the supersonic crack, close enough that Becker's hands trembled on the traverse wheel. Their driver was already reversing, tracks churning mud, as the Panther backed into the tree line. Through the vision blocks, Becker caught one last glimpse of the American tank. Turret rotating, searching for another target. Smoke venting from the penetration hole, but no flames, no detonation, no funeral pyre. Just a wounded machine that refused to die. Inside the Panther, nobody spoke as they repositioned. The commander finally broke the silence, his voice tight with something Becker had never heard before. Not in Russia, not in France, not even during the desperate fighting after the Jabos had come screaming out of the clouds at Mortain. Uncertainty. "Radio Battalion Headquarters. Tell them we achieved penetration on an American tank. No fire observed. Request clarification on ammunition storage for current Sherman variants." Becker keyed the radio, but he already knew what headquarters would say. The same thing they always said when frontline reports contradicted doctrine. The crew had miscalculated the range, misjudged the impact point, failed to achieve true penetration. The manuals were clear. The intelligence was definitive. Shermans burned when you hit the sponsons. Except this one hadn't. And 2 kilometers south, at that very moment, Oberleutnant Hermann Hartz was watching another perfect shot fail to ignite another American tank. The third that morning. Something had changed. The Germans just didn't know what. February 14, 1943, Kasserine Pass, Tunisia. The Jebel Lesouda Ridge burned like a furnace lit by hell itself. Across the valley floor, 23 M4 Sherman tanks from the 1st Armored Division lay scattered in various stages of cremation, some still blazing with white-hot intensity. Others reduced to blackened steel skeletons that radiated heat for 100 meters in every direction. Inside each burned hull, what remained of American tank crews had fused with metal. Oberstleutnant Rudolf Lang, commanding the German battle group that had shattered the American counterattack, walked among the wrecks with clinical interest. His 88mm anti-tank guns had destroyed 18 Shermans in 40 minutes. Of those 18, 16 had burned completely, the internal ammunition exploding with such violence that turrets had been blown 15 feet from their hull rings. The Americans called them Shermans. Lang's men had already coined a different name, Ronsons. Lights first time? Every time. Like the American cigarette lighter advertised in captured magazines. The nickname spread through German ranks with the dark humor of men who had discovered their enemy's fatal weakness. Panzerjäger crews from Tunis to Bizerte learned a simple tactical principle. Any penetrating hit on a Sherman's fighting compartment would likely kill the entire crew. The ammunition stored in sponsons above the tracks, in ready racks beside the gun, in hull racks near the driver, all of it vulnerable, all of it catastrophically flammable when struck by high-velocity steel. The British documented what the Germans already knew. Their operational research section, tasked with analyzing tank losses in North Africa, produced a report that made American ordnance officers physically ill. 65% of knocked-out Shermans burned completely. Not just caught fire, burned until nothing remained but metal and ash. American studies showed worse numbers. The Tank Automotive Center at Detroit Arsenal compiled loss reports from 2 corps and determined that in some engagements, Sherman fire rates exceeded 80%. Crews who survived the initial penetration had seconds, sometimes less, before propellant flames reached another ammunition rack, triggering a chain reaction that turned the entire fighting compartment into a blast furnace. The kill mechanism was understood, but seemingly unavoidable. When an armor-piercing shell penetrated the Sherman's relatively thin side armor, the impact created white-hot fragments and spalling, steel splinters traveling at supersonic speeds inside the crew compartment. These fragments would strike ammunition stored in open racks, igniting the propellant in powder bags or brass cartridge cases. The initial fire would spread to adjacent rounds within seconds. Once 3 or 4 rounds ignited simultaneously, the conflagration became unsurvivable. Tankers developed grim mathematics. A Sherman crew had perhaps 10 seconds after penetration to evacuate, if they weren't already dead from the initial hit, if the hatches weren't jammed, if fragments hadn't shredded hydraulic lines that powered the turret. Traverse needed to rotate the hatches into escape position. Most didn't make it. By summer 1943, after the Sicily campaign added another 100 burned Shermans to the casualty lists, German doctrine had crystallized into tactical certainty. Training manuals distributed to Panzer and Panzerjäger units included detailed diagrams of Sherman ammunition placement. Gunnery instructors at Putlos and Paderborn taught a simple doctrine: aim for the sponsons, aim for the hull sides, and the American tank will eliminate itself. The intelligence was definitive, the tactical guidance was clear, and for 18 months it worked exactly as promised. Until it didn't. Detroit Arsenal, Michigan, April 1943. Colonel James Taylor stood in a warehouse filled with death, or rather, what death left behind when Sherman tanks burned. 17 hulls, shipped back from North Africa at enormous expense, sat in various states of destruction. Some were merely scorched. Others had been gutted so thoroughly that rivet heads had melted into metallic tears running down interior walls. The U.S. and the Army Ordnance Department's Tank Automotive Center had a singular mission: determine why American tanks burned, and determine it fast, because the answer everyone assumed, gasoline engines, might be wrong. Taylor walked past Sherman number A7, recovered from Sidi Bou Zid. The fuel tank showed a single penetration hole but remained largely intact, the gasoline having leaked out rather than ignited. Yet the crew compartment was completely immolated. He made a note on his clipboard and moved to the next wreck. The forensic work was methodical, brutal, and revelatory. Ordnance metallurgists cut apart each hull, documenting every burn pattern, every fragment trajectory, every point where metal had reached temperatures sufficient to weaken structural steel. They reconstructed penetration angles using German shells recovered from battlefields, 75 mm and 88 mm that had failed to detonate but remained embedded in armor plate. They mapped crew positions based on what remained. The pattern emerged within 2 weeks. Ammunition propellant, not gasoline, caused most catastrophic fires. In hull after hull, investigators found fuel tanks punctured but unburned. They found engine compartments penetrated without significant fire damage. But they found ammunition storage areas, sponsons, ready racks, floor bins, transformed into blast zones where temperatures had exceeded 3,000 degrees Fahrenheit, hot enough to melt steel, hot enough to vaporize human remains. The chemistry was straightforward once they understood it. Sherman ammunition used nitrocellulose-based propellant packed in brass cartridge cases or cotton bags. When armor-piercing shells penetrated the fighting compartment, they created supersonic steel fragments and armor spalling that acted like incendiary shrapnel. These fragments, superheated by friction and impact, would strike exposed ammunition. Nitrocellulose propellant ignited at approximately 340 degFs. The fragments were traveling at temperatures exceeding 1,800 degF. One round igniting would create enough heat to cook off adjacent rounds within 2 to 3 seconds. Once 4 or 5 rounds burned simultaneously, the chain reaction became unstoppable. The fire would consume all 70-plus rounds stored throughout the fighting compartment in less than 30 seconds, generating temperatures that turned the Sherman into a crematorium. The gasoline, ironically, rarely contributed to crew deaths. By the time fuel fires started, usually after the crew was already dead, the ammunition had already done its work. Major Eugene Peterson, the metallurgist leading the investigation, compiled the findings into a report that landed on desks at Aberdeen Proving Ground with the impact of a bomb. Current ammunition storage methods present unacceptable crew survivability risk. Solution requires fundamental redesign of storage configuration and fire suppression methodology. The conclusion was stark, the implications staggering. Every Sherman rolling off production lines, Fisher Body in Michigan, Pressed Steel Car in Pennsylvania, Chrysler in Delaware, was being built with a design flaw that killed more American tankers than German guns. The fuel wasn't the problem. It had never been the problem. The ammunition was killing American crews from the inside. And now Ordnance knew exactly what needed to change. Aberdeen Proving Ground, Maryland, November 18, 1943. The tank board meeting had been grinding through its agenda for 3 hours. Armor thickness debates, transmission reliability issues, the perpetual argument over 75mm versus 76mm main guns. Colonel Taylor was reviewing production schedules when a hand rose from the civilian observers section. "Gentlemen, what if you simply surrounded the ammunition with water?" The room went silent. 20 officers and engineers turned to stare at the man who'd spoken. Dr. Robert Leinbach, a chemical engineer from DuPont's explosives department, attending as a technical consultant on propellant storage. Major Eugene Peterson broke the silence. "I'm sorry, water? Or another liquid?" Leinbach stood, approaching the table where cross-sections of Sherman hulls lay spread across blueprints. "Your metallurgy reports indicate ammunition propellant ignites from fragment impacts and radiant heat transfer. Liquid creates a thermal barrier. It absorbs heat, floods the compartment when containers are penetrated, and saturates exposed propellant before ignition occurs. One of the senior ordnance officers shook his head. "Doctor, we'd be asking crews to fight inside what amounts to an aquarium. The weight alone, I'm not proposing flooding the entire fighting compartment." Leinbach picked up a pencil, sketching rapidly on the margins of a blueprint. Double-walled containers. Ammunition stored in the inner shell. Liquid in the cavity between inner and outer walls. When a shell penetrates, the liquid floods out, suppressing any potential ignition. Taylor leaned forward. "You're describing a jacket system, like water-cooled machine guns." "Precisely, but instead of cooling, we're using thermal mass for fire suppression." The initial concept seemed absurd. Early proposals involved massive water tanks surrounding ammunition racks, adding thousands of pounds, requiring pumps and drainage systems, creating maintenance nightmares. Engineers calculated that filling Sherman sponsons with water would add 3 tons per tank and raise the center of gravity dangerously. But over the following weeks, as ordnance engineers collaborated with DuPont chemists, the concept evolved from impractical to elegant. The breakthrough came from inverting the problem. Instead of protecting existing ammunition rack locations with water, relocate the ammunition to protected positions and build liquid barriers into the storage containers themselves. By early December, the design had crystallized. Ammunition bins repositioned in the hull floor, the area least likely to be penetrated in combat, with each bin consisting of double-walled cells. The gap between walls would be precisely 1.5 inches, filled with approximately 0.5 gallons of liquid per 10-round cell. Total liquid capacity, 36 to 38 gallons per tank, adding roughly 900 pounds, acceptable for the survivability gain. The chemistry proved as critical as the engineering. Pure water froze at 32 WWII, unacceptable for winter operations. Leinbach's team tested various solutions. Water-glycol mixtures prevented freezing, but caused corrosion of brass cartridge cases. Adding rust inhibitors solved corrosion, but created new problems with bacterial growth in stagnant liquid. The final formulation, designated Ammudamp, contained ethyl sodium potassium phosphate with proprietary additives. The mixture remained liquid to 40 degrees, prevented corrosion, inhibited bacterial growth, and actually improved fire suppression characteristics over pure water. By December 15th, Press Steel Car Company in Pennsylvania had received blueprints for the modified ammunition bins. Fisher Body in Michigan was redesigning hull floor stamping dies. Chrysler in Delaware was retooling turret basket assemblies. A chemist's radical idea, proposed in a 3-hour meeting, was about to transform American armored warfare. The first M4 A176W, the W standing for wet, would roll off production lines in 18 days. Fisher Body Plant, Grand Blanc, Michigan. December 28, 1943. The production line didn't stop. That was the mandate from Washington. Do not halt Sherman production. Not for a day, not for an hour. The invasion of France was coming. Date classified but imminent. And General Eisenhower's staff had calculated they needed 5,000 new tanks in European depots before the first landing craft hit the beaches. So Fisher Body's engineers faced an impossible challenge: completely redesign the Sherman's internal architecture while maintaining production rates of 12 tanks per day. Plant manager Harold Webster stood on the assembly floor at 0600 hours, watching the last dry stowage Sherman, hull number 3056, roll toward final inspection. Behind him, overnight crews had already begun installing new stamping dies, modified welding jigs, and retooled assembly fixtures. The changes were comprehensive, almost radical. Hull floors required complete redesign. Where previous Shermans had flat floors with ammunition racks mounted in sponsons above the tracks, the new design featured recessed bins cast directly into the floor plate. deep pockets positioned below the turret basket, where German 75mm and 88mm shells were least likely to penetrate. Each bin was a precision-engineered double-walled container, the inner shell holding 10 rounds of ammunition, the outer shell separated by exactly 1.5 inches, the gap that would contain liquid fire suppressant. The tolerances were machined to within 0.03 inches. Any larger and liquid would slosh excessively during combat maneuvers. Any smaller, and the thermal barrier would prove insufficient. The turret basket presented an even greater engineering challenge. Previous Shermans had full rotating floors that spun with the turret. The new ammunition configuration, with bins in the hull floor, required crews to access rounds that didn't rotate with the turret. The solution? A partial basket, essentially a ring that allowed crew access to hull ammunition through gaps in the turret floor. This meant rerouting hydraulic lines, electrical cables, and control linkages around the new ammunition positions. It meant redesigning the turret traverse mechanism. It meant rebalancing weight distribution for the new 76mm gun being installed simultaneously. Press Steel Car Company in Pennsylvania achieved the transition even faster. Their first M4A1 76W hull number 4001 rolled off the line on January 3, 1944. The W designation, stamped on data plates inside the driver's compartment, stood for wet stowage. Most factory workers didn't know what it meant. Security officers instructed supervisors to avoid discussing the modification outside the plant. By February, both factories were producing only wet stowage variants. The transition had been achieved in 42 days without missing a single day's production quota. Chrysler's Delaware plant completed retooling by March. By April, Pacific Car and Foundry in Washington State had converted their lines. The industrial coordination was unprecedented. 5 major factories simultaneously implementing identical modifications without centralized computer systems, without video conferencing, using only blueprints, telegraph communications, and engineers traveling by train between facilities. The modification added $340 per tank in manufacturing costs. The liquid filling stations required at each factory cost $18,000 to install. Each tank required initial filling of 36 and 38 gallons of Ammudamp solution at $2.80 per gallon. Total additional cost per tank, approximately $450. By June 1944, every Sherman leaving American factories bore the W designation. And in Germany, intelligence analysts working from year-old captured specimens in Tunisia continued distributing tactical guidance based on tanks that no longer existed. The Industrial Revolution had occurred in complete silence. Aberdeen Proving Ground, Maryland, February 12, 1944. The captured German 88mm PaK-43 sat in a reinforced firing position, its barrel aimed across 150 meters of frozen ground at 2 identical Sherman hulls. Both tanks had been stripped of engines and non-essential equipment. Both had been loaded with live 75mm ammunition. 70 rounds per tank, positioned exactly as combat loading procedures specified. The only difference? Tank A retained the original sponson-mounted dry stowage racks. Tank B had been fitted with the new wet stowage bins, filled with 37 gallons of Ammudamp solution. Major Eugene Peterson stood in the observation bunker, watching through reinforced glass as technicians made final adjustments to the high-speed cameras. 16mm film would capture everything at 200 frames per second. The Army wanted documentation, irrefutable proof that the modification worked before committing billions of dollars to full production conversion. "Ready on the firing line," came the call over the intercom. Peterson keyed his microphone. "Commence test sequence alpha. Target, dry stowage. Sherman, right sponson." The 88mm fired with a crack that shook the observation bunker's concrete walls. Through binoculars, Peterson watched the armor-piercing shell punch through the Sherman's side armor with surgical precision. Exactly where German doctrine taught their gunners to aim. Exactly where American tanks had been dying for 2 years. 3 seconds. Black smoke began curling from the penetration hole. 5 seconds. Orange flames erupted from every hatch, the internal ammunition igniting in a cascading chain reaction. The propellant fire reached temperatures sufficient to make the entire hull glow dull red. Secondary detonations blew the turret hatches open. Flames shot 15 feet into the winter air. The cameramen kept filming as the tank burned for 11 minutes before collapsing into a blackened skeleton. Peterson made notes on his clipboard with hands that weren't entirely steady. He'd seen this before, in North Africa, in Sicily, in warehouses filled with burned hulls shipped back for analysis. But watching it happen in controlled conditions, knowing exactly what was occurring inside that hull, made it worse somehow. Prepare Test Sequence Beta. Target: Wet Stowage Sherman, identical impact moment. The second 88mm shot was equally precise. The shell penetrated the right side armor, fragments screaming through the crew compartment at supersonic speeds, striking the ammunition bins positioned in the hull floor. Peterson counted seconds. 3, 4, 5. A thin wisp of gray smoke vented from the penetration hole. Nothing more. 10 seconds. 15. 20. No flames. No secondary explosions. No catastrophic detonation. Through binoculars, Peterson could see liquid pouring from the penetration hole. The Ammudamp solution flooding out of the compromised, double-walled bins, soaking any exposed propellant before ignition could occur. Some smoke continued venting, but the small fire inside was already self-extinguishing as liquid saturated the compartment. After 2 minutes, the smoke stopped entirely. The tank sat silent, penetrated but not burning, exactly as designed. Over the following 3 weeks, Aberdeen technicians conducted 47 additional tests, varying impact angles, shell types, and penetration locations. They used captured German 75mm and 88mm ammunition. They fired at point-blank range and at combat distances. They struck ammunition bins directly and tested fragment dispersion patterns. The statistics were irrefutable. Dry stowage, 73% burn rate after penetration. Wet stowage, 15% burn rate after penetration. The film footage, later classified secret and locked in Ordnance Department vaults until 1963, captured the contrast with devastating clarity. Reel after reel showed dry stowage Shermans erupting into infernos, while wet stowage variants produced brief smoke and self-extinguishing fires. One test remained particularly striking. Technicians deliberately positioned thermite grenades inside a wet stowage ammunition bin and detonated them remotely. The Ammudamp solution absorbed the initial heat, flooded the compartment, and extinguished the thermite reaction before it could spread to other rounds. The system worked beyond projected specifications. Peterson compiled the data into a report stamped, restricted, and delivered it personally to the Ordnance Department's Chief of Tank Automotive. Wet stowage reduces crew fatal fires by approximately 80%. Recommend immediate full production implementation. By the time his report reached Washington, Fisher Body had already produced 847 wet stowage Shermans. The proof existed on film, locked in vaults. The tanks existed in depot yards across England, waiting for combat. And German intelligence had no idea any of it existed. Near Saint-Lô, Normandy, July 25, 1944, 09:38 hours. The sky disappeared beneath 3,000 Allied bombers. For 90 minutes, carpet bombing transformed German defensive positions into a moonscape of overlapping craters, shattered concrete, and disintegrated panzer companies. When the last B-17 turned for England and smoke finally cleared, American armor surged through the gap. Leading the assault, the 2nd and 3rd Armored Divisions, equipped with 104 M4A376W Shermans, the first wet stowage tanks to see combat in the European theater. Panzer Lehr Division, already devastated by the bombardment, positioned its surviving Panthers and Panzer IVs in hasty ambush positions among the hedgerows south of St. Lo. Crews loaded armor-piercing rounds and waited for the Americans to drive into killing range. The engagement began exactly as German doctrine predicted. Panthers achieved first-round hits at 800 meters, textbook gunnery, perfect shot placement into Sherman hull sides and sponsons. Commanders watched through optics, counting seconds until the inevitable fires. The fires didn't come. Lieutenant Friedrich Weber, commanding a Panther from Panzer Lehr's remnants, fired 3 times at a Sherman from the U.S. 67th Armored Regiment. All 3 shots penetrated. His gunner, Unteroffizier Rolf Mann, achieved impacts exactly where training prescribed. Right sponson, left sponson, lower hull. The Sherman reversed into cover, trailing smoke but not flames. Unmöglich, Mann whispered. Impossible. Weber's radio crackled with similar reports from other Panthers. Penetrations achieved, no catastrophic fires observed. Shermans withdrawing under their own power or returning fire from positions where they should have been burning hulks. The German after-action reports, captured 2 weeks later when Panzer Lehr's headquarters was overrun near Coutances, reflected confusion evolving into genuine alarm. Multiple successful penetrations on American medium tanks failed to produce expected results. Targets demonstrated unexpected resilience. Several tanks struck in ammunition storage areas did not burn. Enemy armor withdrawing and repositioning at rates inconsistent with projected damage. What Weber couldn't know, of the 14 Shermans his battalion claimed destroyed that day, 9 would return to combat within 48 hours after field repairs. The penetrations he'd achieved had holed hulls and wounded crews, but the wet stowage ammunition systems had functioned exactly as designed. Liquid flooded damaged compartments, saturating propellant, preventing the chain reaction fires German tactics depended on. By July 28th, as Operation Cobra broke German lines and American armor raced toward Avranches, Wehrmacht intelligence officers were receiving dozens of similar field reports. Shermans surviving hits that should have been fatal. American armored strength regenerating at impossible rates. Crew casualties lower than mathematical projections predicted. Staff officers dismissed most reports as exaggerations from combat-stressed crews. The intelligence was clear. Shermans burned when properly engaged. The manuals said so. The data from Tunisia and Sicily confirmed it. If frontline Panthers weren't achieving expected results, obviously the crews were missing ammunition racks or miscalculating penetration. No one considered that the ammunition racks might have moved, that the fundamental characteristics of American armor might have changed, that every tactical assumption built over 18 months of combat had become obsolete in January 1944. The 2nd Armored Division's War Diary for July 25th and 31st recorded 23 Shermans knocked out during Cobra. 14 returned to service within 72 hours. German intelligence, calculating from doctrine, assessed all 23 as total losses. The mathematics of armored warfare had broken. Germany was still using the old formula. Kummersdorf Proving Ground, Germany. August 1944. The training manual sat open on the desk of Hauptmann Ernst Hoffmann, chief gunnery instructor for replacement panzer crews being rushed to Normandy. Page 47 contained detailed cross-section diagrams of the M4 Sherman, based on intelligence analysis of tanks captured at Kasserine Pass and Sidi Bouzid in early 1943. Red shading highlighted the sponsons, the hull sections above the tracks where American ammunition sat in open racks, vulnerable and catastrophically flammable. Arrows pointed to optimal impact points. Text read, penetration of sponson area will ignite ammunition stores. Target is priority for immediate vehicle destruction. Hoffman had taught from this manual for 11 months. Every panzer gunner graduating from Kummersdorf, Putlos, and Paderborn schools learned the same doctrine. The intelligence was definitive. The tactical guidance was gospel. And in Normandy, it had stopped working. 300 kilometers west, Oberfeldwebel Klaus Richter crouched beside his Panther in a Norman apple orchard, arguing with his gunner over a shot fired that morning. They'd engaged a Sherman at 400 meters. Perfect range, perfect angle, perfect sight picture. The 88 8mm round had struck exactly where Richter had aimed. The right sponson, precisely matching the red-shaded target area from training diagrams. The Sherman had not burned. "You pulled left," Richter insisted. "The impact was too high." His gunner, Unteroffizier Dieter Kohler, shook his head. "I watched the tracer, Herr Oberfeldwebel. Dead center on the sponson. The shot was perfect." "Then you missed the ammunition. Hit structure instead of racks. That's impossible." "The drawings show, the drawings are correct. You missed." But Kohler hadn't missed. None of them had missed. The ammunition simply wasn't where German intelligence said it would be. Since January 1944, American factories had been relocating Sherman ammunition from sponsons to double-walled bins positioned in the hull floor, the area least likely to be penetrated in combat, protected by belly armor, positioned below the turret basket where German gunners rarely aimed. German doctrine, frozen in 1943, still directed crews to target sponsons that now contained nothing but fuel cells, tools, and personal equipment. Every textbook shot at sponson ammunition racks was hitting empty space. The psychological impact proved devastating. Panzer crews, trained for months on specific targeting doctrine, began doubting their skills when perfect shots failed to produce expected results. Commanders blamed gunners for missing. Gunners blamed loaders for slow loading that allowed targets to maneuver. Loaders blamed commanders for poor positioning. No one blamed the intelligence because questioning intelligence meant questioning the entire tactical framework that had worked successfully for 18 months. Feldwebel Heinrich Bauer, a veteran Panther commander from the Leibstandarte, wrote in a letter captured near Falaise, "We achieve penetrations, but Americans refuse to burn. Crews are becoming demoralized. They believe they cannot shoot properly anymore. I have seen men weep after perfect shots fail to destroy enemy tanks." German after-action reports from August 1944 reflected the doctrinal collapse. Crews report accuracy problems despite range card compliance. Enemy armor demonstrates unexpected survivability. Request updated intelligence on American tank modifications. The requests went nowhere. Intelligence officers, working from comprehensive technical evaluations completed in 1943, saw no reason to reassess. The Sherman's characteristics were documented, catalogued, distributed. If frontline crews weren't achieving expected results, the fault lay in execution, not evaluation. At Kummersdorf, Hoffman continued teaching replacement crews to aim for the sponsons. In Normandy, those crews continued firing at ammunition that no longer existed in those locations. And somewhere in the bureaucratic layers between front and headquarters, the truth drowned in paperwork. No one read. Aricourt, Lorraine, France, September 19th to 29th, 1944. The largest tank battle on the Western Front unfolded across rain-soaked fields east of Nancy. The U.S. 4th Armored Division, equipped with 177 M4 Shermans, most bearing the W designation, collided with the German 5th Panzer Army's counteroffensive. 262 Panthers and Panzer IVs attempting to crush General Patton's exposed flank. For German intelligence officers tracking the battle from maps in Metz, the mathematics seemed favorable. By September 29th, Wehrmacht reconnaissance and after-action reports documented 151 American medium tanks knocked out, struck by 75mm, 88mm, and 128mm anti-tank fire at ranges from 200 to 1,200 meters. Penetrations confirmed by German crews. Hits observed. Targets neutralized. Standard doctrine prescribed a simple calculation. Penetrated Sherman equals destroyed Sherman equals permanent loss to American combat strength. Generalleutnant Otto von Knobelsdorff, commanding 1st Army, assessed the 4th Armored Division as combat ineffective. Loss rates exceeding 85% meant the American formation should require weeks to reconstitute. The counteroffensive, though ultimately contained, had achieved its strategic objective, mauling Patton's spearhead badly enough to halt the Allied advance toward the Saar. The reports went to Berlin. The maps were updated. The red marks indicating destroyed American armor spread across Lorraine like a rash. The calculation was wrong. Catastrophically, strategically wrong. Of the 151 Shermans knocked out at Aricourt, 110 returned to combat within 24 to 72 hours. Penetrated hulls were patched, damaged transmissions replaced, wounded crew members evacuated and replaced by men from replacement depots. Tanks towed to field maintenance companies returned to frontline service faster than German intelligence believed physically possible. The wet stowage ammunition systems had fundamentally changed the equation. Shermans that should have burned, that would have burned in 1943, now survived as repairable vehicles. The U.S. Army's Ordnance Company, positioned 15 kilometers behind the front, processed an average of 11 damaged Shermans per day. Welders sealed penetration holes. Mechanics replaced bogie wheels, track sections, gun barrels. Most repairs required 18 to 36 hours. By October 2nd, the 4th Armored Division reported 164 operational Shermans, more than they'd started with because replacement tanks from depot stocks had arrived faster than losses accumulated. German strategic planning collapsed into confusion. Oberst Heinrich von Luttwitz, commanding the 47th Panzer Corps that had fought at Aricourt, submitted a report marked Urgent to Army Group G headquarters. Enemy armor strength regenerating at rates inconsistent with observed losses. American tank formations appear to possess unlimited replacement capacity, or losses are significantly overestimated. Request clarification. The response from intelligence staff was bureaucratic and dismissive. Frontline assessments likely conflate different American units. Maintain standard loss calculation methodology. But von Luttwitz's assessment was neither confused nor exaggerated. He had correctly identified that German mathematics no longer reflected battlefield reality. The formula, penetration equals destruction equals permanent loss, had been accurate in Tunisia, in Sicily, even in the early weeks of Normandy. It simply wasn't true anymore. The German 5th Panzer Army had expended 70% of its operational armor, destroying 41 American tanks. The actual permanent losses at Aricourt. They had achieved 151 penetrations, but only 41 kills. The difference, 110 tanks saved by liquid-filled ammunition bins that prevented catastrophic fires. German intelligence never recalculated the formula. Planning staffs continued using 1943 loss ratios to estimate American armored strength throughout France, into the Ardennes, across the Rhine until the war's end. They fought a ghost army that existed only in their outdated arithmetic, always stronger than they calculated, always regenerating faster than mathematics predicted. The numbers had stopped making sense in January 1944. Germany didn't notice until it was far too late. Near Stavelot, Belgium. December 18, 1944. 0340 hours. Obersturmbannführer Joachim Peiper's armored spearhead, the most powerful formation in the entire Ardennes offensive, had been stopped cold by a single American roadblock, 17 M4 Shermans from the 743rd Tank Battalion positioned across the road to the Meuse River. His lead Panther fired at point-blank range, less than 100 meters. The 75mm shell punched through a Sherman's bow armor with a flash that illuminated fog-shrouded trees. Peiper watched through binoculars, waiting for the explosion, the flames, the burning hulk that would signal his column could advance. The Sherman's engine died. The turret remained motionless, but no fire came. Verflucht! Peiper's voice carried an edge his staff officers had never heard before, not in Russia, not in Normandy, not during 2 years of Waffen-SS operations, not anger. Something worse, uncertainty. His formation engaged the American roadblock for 40 minutes. Panthers and Panzer IVs fired at ranges where misses were impossible. They achieved penetrations. Peiper personally observed at least 9 successful hits on Sherman hulls. 4 American tanks burned. 13 did not. When American crews finally abandoned their positions and withdrew into the forest, Peiper's column advanced past knocked-out Shermans that sat silent in the darkness, holed, smoking, disabled, but not consumed by the ammunition fires German doctrine promised. His after-action report, captured when Peiper surrendered in January, contained a passage that intelligence officers would flag and underline. American medium tanks demonstrate unexpected resistance to fire after penetration. Multiple successful hits observed without producing catastrophic ammunition explosions. Enemy appears to have modified internal arrangements, though specifics unknown. Peiper had come closer to the truth than any German officer in 18 months of combat. But his report, filed to ISS Panzer Corps headquarters during the chaos of the Bulge's collapse, disappeared into administrative backlog and was never forwarded to technical intelligence. The pattern repeated across the Ardennes salient. German formations achieved tactical penetrations, but strategic mathematics continued failing. Kampfgruppe commanders calculated American armor losses based on doctrine, planned subsequent advances based on those calculations, then encountered American tank formations at unexpected strength. General Major Siegfried von Waldenberg, commanding the 116th Panzer Division near Hotten, wrote in his war diary, "We destroy their tanks and they return. We count losses and the numbers prove false. American armor refuses to behave according to established principles." The 2nd Panzer Division's intelligence officer submitted a report to 5th Panzer Army on December 23rd. Significant discrepancy between tanks knocked out and permanent American losses. Request investigation into potential armor modifications. The request was filed. No investigation occurred. At Ronson, the Wehrmacht High Command's Operations Center outside Berlin, staff officers calculated American armored strength in the Ardennes using loss ratios derived from Tunisia and Sicily. Their projections showed U.S. forces critically weakened, unable to contain the German offensive. The projections were wrong. On December 26th, when Patton's Third Army counterattacked into the southern shoulder of the Bulge, his 4th Armored Division, supposedly mauled at Aricourt 3 months earlier, attacked with 165 operational Shermans. German intelligence had calculated they possessed perhaps 80. By December 28th, Kampfgruppe Peiper, surrounded at La Gliese, abandoned its vehicles and escaped on foot through American lines. Among the equipment left behind, Panthers and Tigers that had achieved dozens of successful penetrations against Shermans. Peiper's after-action interrogation, conducted by U.S. intelligence in January 1945, included a statement. "Your tanks do not burn as they once did. This was not in our briefings. We were not prepared for this change." The interrogator noted the comment but didn't pursue it. The reason seemed obvious. Americans had simply been lucky, or German gunnery had declined. No one told the interrogator about the W designation. No one explained the liquid-filled bins. The truth remained classified, secret, locked in Ordnance Department files. And Germany fought to the end, still aiming for ammunition that wasn't there. Sennelager Testing Facility, Germany, March 1945. Oberst Rudolf Becker stood in front of an American M4A3 76W Sherman, captured intact near Remagen 3 weeks earlier. The tank had been transported to Germany's premier technical intelligence facility for comprehensive evaluation. The first detailed analysis of American armor since the Tunisia specimens of 1943. Becker had requisitioned this evaluation in October 1944, after frontline reports describing unusual Sherman survivability had accumulated to levels impossible to dismiss. The request had taken 5 months to process through Wehrmacht bureaucracy, 5 months during which Germany lost the Ardennes, the Saar, and the Rhineland. Now, finally, he had his captured Sherman, except the tank wasn't there. "What do you mean, used in combat?" Becker's voice was carefully controlled, the tone of a man who had learned not to show anger in front of subordinates. The lieutenant from the testing facility shifted uncomfortably. "Herr Oberst, the tank was requisitioned by Panzerjäger Abteilung 512 on March 4th. They needed immediate replacements after this tank was marked for technical intelligence evaluation. That designation carries priority over not higher than combat operational requirements, Herr Oberst. The requisition came from Army Group B. The paperwork was proper." Becker walked to the empty space where the Sherman should have been positioned, surrounded by measurement equipment, photography stations, and disassembly tools. His staff had prepared for a week, arranging metallurgists, ammunition specialists, armor analysts. They would have documented every modification, every design change, every detail that differed from the 1943 evaluations. Now the tank was fighting somewhere on the Ruhr front, crewed by Germans, likely to be destroyed before any technical assessment occurred. This wasn't incompetence. It was a systematic pattern that had repeated throughout the war. Every intact Sherman captured since January 1944 had followed the same trajectory. Tagged for intelligence evaluation, then requisitioned by frontline units desperate for operational vehicles. German mechanics would perform basic maintenance, repaint the markings, and send the tanks into combat where they'd be destroyed, often within days. The technical intelligence that might have revealed wet stowage, relocated ammunition bins, and modified internal configurations never occurred because the evidence kept being sent back into battle before analysis. Becker had seen this before. In July 1944, a Sherman captured near St. Lo had been scheduled for Kummersdorf evaluation. It was diverted to Panzerlehr as a replacement vehicle and knocked out at Coutances. In September, a specimen from Aracourt was repainted and issued to a training battalion where it was destroyed during an Allied air raid before technicians could examine it. In November, 3 Shermans captured during the Metz fighting were sent to Sennelager. 2 were requisitioned by emergency repair depots for spare parts. The third was stripped for its engine before the evaluation team arrived. The pattern wasn't malicious. It was simply the reality of Germany's desperate material situation. Captured American vehicles represented operational assets, too valuable to waste on analysis when frontline units were reporting critical equipment shortages. But the cost of that desperation was intelligence blindness. Hauptmann Ernst Hoffmann, still teaching at Kummersdorf, continued instructing replacement crews using manuals based on 1943 data. Rangefinders at Putlos still calculated penetration probabilities based on ammunition stored in sponsons. Tactical doctrine distributed to the last panzer formations defending Berlin still recommended targeting areas where Sherman ammunition hadn't been stored since January 1944. Baker submitted his report to OKW Intelligence. Unable to complete technical evaluation, recommend immediate priority protection for captured enemy armor specimens pending analysis. The report was filed on March 28, 1945. Germany surrendered 40 days later. The comprehensive technical evaluation of wet stowage Shermans, the analysis that might have explained 18 months of unexpected American armor survivability, never occurred. Detroit Arsenal, Michigan, August 15, 1945. Colonel James Taylor stood in the same warehouse where, 28 months earlier, he had walked among 17 burned Sherman hulls from North Africa. Today, the space held a different kind of evidence. 3 wet stowage Shermans, returned from Europe after penetrations that should have killed their crews. Hull A1447 had been struck twice near St. Lo. The crew survived both hits, repaired the tank within 36 hours, and fought it through France, Belgium, and into Germany. Hull B2891 had taken 3 penetrations at Aracourt. The crew evacuated after the 3rd hit, but the tank returned to service with a replacement crew 4 days later. Hull C3356 had been penetrated during the bulge, burned briefly when a fragment ignited personal equipment, but the wet stowage bins had prevented ammunition ignition. The crew extinguished the fire with onboard extinguishers and withdrew under their own power. All 3 tanks were scarred, patched, welded. All 3 had brought their crews home alive. Taylor had the statistics memorized. From June 1944 through May 1940, U.S. forces in Europe lost approximately 40,200 Sherman tanks to enemy action. Of those losses, dry stowage Shermans, pre-January 1944 production, 68% burned after penetration. Wet stowage Shermans, post-January 1944 production, 15% burned after penetration. The modification had reduced catastrophic ammunition fires by 78%. The Ordnance Department's final analysis, compiled in October 1945, calculated that wet stowage had prevented approximately 3,200 Sherman fires that would have occurred under 1943-era configurations. With average crew size of 5 men and estimated 60% crew fatality rates in ammunition fires, the system had likely saved 9,600 American lives, nearly 2 full armored divisions worth of trained tank crewmen. But the strategic impact extended beyond crew survivability. Wet stowage tanks that were penetrated but didn't burn could be recovered, repaired, and returned to combat. The U.S. Army's maintenance pipeline, ordnance companies positioned 15 to 30 kilometers behind front lines, processed damaged Shermans at rates that shocked German intelligence officers during post-war interrogations. General Major von Waldenberg, when shown American maintenance records from the 4th Armored Division, refused to believe the numbers. "You are telling me that tanks we counted as destroyed returned to battle within days? That is impossible. Our calculations would be meaningless." "Your calculations were meaningless," the interrogator replied. The multiplication effect proved decisive. A single wet stowage Sherman might be knocked out, repaired, and returned to combat 3 or 4 times during a campaign, each time counted by German intelligence as a separate vehicle destroyed. German planning staffs calculated American armor losses at 150% of actual permanent losses in some operations. The strategic deception was entirely unintentional, a byproduct of German intelligence working from obsolete data, while American engineering quietly revolutionized armored warfare survivability. Wet stowage never appeared in headlines. It earned no dramatic citations. Crews who survived because of it rarely knew the system existed. They simply knew their tank had been hit and somehow hadn't burned, and they were grateful for whatever luck or divine intervention had spared them. The modification cost $450 per tank. Total program expenditure, approximately $11 million. Return on investment, incalculable. On September 2, 1945, when Japan surrendered aboard USS Missouri, the last Sherman tanks rolling off American production lines bore the W designation. By then, 29,017 wet stowage Shermans had been manufactured, the single largest production run of a modified armored vehicle in military history. Colonel Taylor walked past hull C-3356 one final time, running his hand along a welded patch that covered an 88mm penetration hole. The crew had painted their tank's name on the glacis, "Lucky Strike." Taylor smiled slightly. Luck had nothing to do with it, just chemistry, engineering, and a DuPont chemist's radical idea in a November 1943 meeting. An innovation so effective, so quiet, so invisible that the enemy never understood what had changed. The best kind of weapon, the one they never see coming.